Hey everybody, this is the very first sort of full lecture in the software engineering course, and I am Chris Mills, and today what we're going to be talking about is how the practice of software engineering is fundamentally different than what I'm going to loosely refer to as big air quotes coding, which is something closer to what you've probably been doing in other classes or kind of doing as a hobby on the side. So the place we're going to start is probably the place that's the most familiar to you. And so that would be a programming assignment. So if you think about going back to data structures or going back to one of the very first sort of intro to programming classes, you have probably written a non-trivial number of programming assignments, maybe dozens, maybe 100. And at this point, you realize that the aggregation of all of those lines of code is not a small amount of effort on your part, but it's in a lot of ways fundamentally different from what you would be doing as a software engineer going forward. And so this is kind of where we want to start. So my first claim in this lecture is that while you could do things a certain way in a programming assignment and things more than likely kind of worked out, the process that you need to actually perform at scale software engineering is fundamentally different than that sort of ad hoc process that you used to create just a programming assignment piece of code. And so here we refer to production software. What that means is that software that's used by someone at scale or in an online fashion. So your bank is using production code to deposit your checks, to deposit your paycheck into your banking account, things like that. So when you are looking at production software that's actually in use by people in a real life day-to-day situation, the way that you create that code, the way that you create those pieces of software is a little bit more metered and it's a little bit more structured than the processes that you've been using to do programming assignments, which kind of makes sense. So in order to kick off the class, what we want to do is take something that's really, really familiar to you and think about all of the ways that that really familiar situation is different than the situation that you're ultimately trying to probably get a job in. So we want to look at the differences between a programming assignment and a piece of software that you would actually create as a software engineer for the purposes of day-to-day use. So the first thing about our programming assignment is that these things are pretty much exclusively for a grade. You are not very often doing programming assignments just for your own health. Potentially you're contributing to open source software, something like that. That's much more close to a production software engineering situation, but programming assignments from just a college or a course perspective are almost always for a grade, and that fundamentally makes them different. Also, these things have really well-defined and kind of abrupt timelines. So you get a rubric. The rubric says you have to use XYZ library in order to read in a string and parse that string and do these 6 tasks. And by the way, you have to have it done in 2.5 weeks, and that's kind of it. And you also have temporal locality with coding concepts. And so if you remember from computer organization, temporal locality is the idea that you have been given some information very recently that you're going to end up using right now. So it is very unlikely in especially intro to programming classes that you would have to call on information that you were given maybe a year or 2 or 3 years beforehand. Typically you go through a unit about arrays or you go through a unit about object-oriented programming, and then you kind of immediately use those concepts in order to perform the programming task that you're given. And in general, these programming assignments really have a low ceiling of negative impact on your life. So let's take the worst case scenario. If you made a 0 on a programming assignment in 3330, could you fail the class? Absolutely. If you failed the class, would you immediately die? Probably not. Would some catastrophic event happen that had a significant impact on human life happen? Probably not. So even though a lot of the times in your sort of student experience, bad grades seem like the sky is falling, it's very unlikely that the sky would actually fall if you did poorly on a programming assignment. These things are often short, and they're often really intended for you to do by yourself. So you don't necessarily have to deal with the complexity of having 6 of your best friends trying to do the same task as you at the same time. You don't necessarily have to deal with synchronizing effort. You don't necessarily have to deal with splitting up the work so that everything is equitable. You just sort of take a list of tasks and you do them yourself, and you get the result that you would expect. And while that sounds easy enough on paper, you obviously have experienced times where programming assignments are extremely not easy. My claim here is that it's even less easy if you also have to deal with all of the sort of sociological aspects of teamwork around those programming assignments. So why do these things matter from a having differences with software engineering tasks perspective? So basically, if you are looking at something for a grade, you can look at the syllabus, you can figure out, hey, this one programming assignment is only worth 4 points in the grand scheme of things. And if I have another assignment due on the same day, maybe I can take the late penalty and then everything will be fine. Or you can kind of optimize your sense of failure. You can figure out what safety nets you have available, and you can kind of quickly take those as you need them. And the fact that they have well-defined abrupt timelines really only allows you to procrastinate so much. And it gives you this idea that you can put off the programming assignment for maybe a week on a 2-week assignment, and then you can scramble for 5 days, and then at the end of the day, maybe you can pull it out. And if not, you can always go back to the previous point that it's just a grade and kind of deal with it from there. And in most of these cases, you also have a textbook to reference, you have lecture slides, you have notes from the lecture, and you don't necessarily have to search the breadth of the whole textbook or the entire internet or the entire list of course notes that you have. You know that the programming assignment really is about the last 2 weeks of information, or it's about the last month of information. And so you have a very kind of narrow window of searchable material that you can go to for answers to questions. And at the end of the day, if you fail a class, you can always take it again. So even though it might be embarrassing, even though it's not necessarily a thing that you want to pay for twice, you can always kind of very easily recover from a failure if it's just failing a class. And as we talked about a little bit ago, there are tons of sociological issues with teamwork. And so while it might seem trivial to work in a team, it is very much not trivial to work in a team. And actually one of the ABET requirements of this course is to kind of force you to work in a teamwork environment so that you pick up on all of these subtle nuances of sociology that make teamwork very, very, very difficult. So while it is very possible in a software engineering context to have a strong disagreement with a team member about how a thing should be implemented or what tools should be used or what framework is best for the application, it is extremely unlikely that that would happen if you were just a single person trying to perform a programming task for a course that you're taking. So to go back to the top, right, software engineering tasks are not for a grade. They're often to keep your job, right? If you can't actually perform the task, or if you do the task very poorly, you could absolutely lose your job. And so instead of failing a class, what you've done is you have eliminated your ability to pay your rent, and now you have much further to fall than just failing a class. Also, you don't necessarily have the safety net of being able to go back to the textbook. Of course, you can always go to Google and try to figure out things that you don't necessarily understand, but the context around software engineering tasks at scale is basically the wide world of the universe. It isn't necessarily just 2 weeks of material that was presented to you in a class. So you can start to see that the software engineering tasks are much larger, but they're also more amorphous. You don't necessarily have these well-defined criteria for success, and you don't necessarily have safety nets that you have in the university to kind of help you when you fail. So what I want to be clear about is a lot of people that do not have computer science backgrounds and really code more for a hobby than anything call themselves coders. They call themselves developers. They call themselves tons of different things that in a lot of ways kind of overstate their ability to do things. And so I first challenge you not to use those terms to refer to yourself, particularly for job applications and that kind of thing. And the reason is because coding is basically just a verb, right? If you were to go to Excel and you were to write a bunch of VLOOKUPs and you were to use the equal sign to code some formulas that aggregated some columns inside of an Excel spreadsheet, technically you could call yourself a coder. You have developed a spreadsheet inside of Excel, and we all kind of know that there is a drastic difference between coding in huge air quotes in Excel and actually developing scalable software solutions with C++ or Java or C#. So the important thing about this verb or about this word that a lot of people are using on job applications, for example, is that it doesn't imply intent. So a software engineer does not just kind of code for their own health. They don't code for the fun of it in a lot of ways. They code for solving a specific problem. So while a person could code for their own educational purposes, or they could code for a hyper-specific need inside of their job, what we are looking at in this course is coding for a specific purpose, coding to solve a problem that potentially the client that's coming to us doesn't even understand how to quantify themselves. So to be a little bit pedantic, software engineers produce code. So software engineers are coders, but the converse of that statement is not necessarily always true. So if you have friends who are in psychology or wherever, statistics, and they're trying to get a software engineering job, and what they do is they try to contextualize themselves as a person who is technical in nature and can write a bunch of code. That's great, and that will certainly check a box, but it doesn't necessarily mean that they're checking all of the boxes that a software organization wants in a software engineer. It's much more than just kind of opening Vim or opening Visual Studio, typing a whole bunch, and then having a thing that compiles. So software engineering, if we wanted to provide kind of a textbook definition, is taking a problem that somebody has presented to you and creating a very concrete solution to that problem in the form of software. So more than just the ability to write code in a specific language, C, C++, C#, Java, whatever, a software engineer has to be able to write the code, has to be able to debug the code, has to be able to test the code, but they also have to be able to manage all of this interstitial sort of soft skill stuff that sits around the coding involved in software engineering. And so that's a lot of what this course is focused on, is A, making you aware that these soft skill situations exist, and B, helping you kind of navigate them. So as we'll start talking about next week, the very first sort of step in the software development lifecycle is trying to gather all of the requirements from a client that has a problem to help them identify what the problem is. So this goes back to how programming assignments can be very, very, very rigidly structured. You can be given a rubric. In software engineering, very rarely are you given a rubric. And so basically what you have to do is you have to go to the client site and you have to play the role of what I refer to as the bartender slash therapist slash manager. You kind of have to divine from them what their struggling points are, what things don't necessarily work for them with their current system, what the system needs to look like. And then you have to take all of this kind of qualitative data and then put that into a quantitative form that a software organization can use to actually create the concrete solution that the client actually needs to do their job. So that is drastically different than even harder programming assignments that you might see in operating systems or in CompOrg 2, where you're having to build fairly complex simulators. It's sort of that, but on overdrive. You're trying to go to clients in various industries that you yourself may not understand, and you're having to help them figure out what a solution for their problems look like when maybe they don't even understand their problems to begin with. Another thing about this is that you don't necessarily just want your solution to fit that one client's hyper-specific situation. You ideally want to be able to solve problems generically because then you can take the same code that you've written to solve client A's problems, and then you can resell that to client B to solve their same problems. And A, you get more revenue, and B, the client doesn't have to wait for that wheel to be reinvented. Another thing is that, like we said before, most software is not developed by a single person. There are certainly instances, there's sysinternals that was created largely by Mark Russinovich by himself. That's the outlier, not necessarily the common case. So you will see software that has been generated by teams of hundreds or thousands of people, and trying to work in large teams is not a thing that's trivial, and there is a substantial amount of research around how to make that more efficient and kind of emulate the individual developer experience that everybody's kind of used to and works best in. And this last point is really, really important, and I think may make more sense maybe as an example. So we have all been through a programming assignment where we kind of flub it, because sort of fake it until you make it kind of situation, and it passes your tests, and you kind of know that you're going to get some points counted off for one or two or three features that you just didn't get a chance to actually solidify. And that's kind of okay, because in a programming assignment, yeah, you'll make an 81, but you know that you can kind of recover in the later parts of the class and everything's okay. In software engineering, you can't necessarily do that, because in a lot of cases, you could be generating a piece of software that will be around 30 or 35 years after you have created the piece of software. So in software engineering in general, you have to be able to stand by your code for potentially decades. So if you release a piece of software with a known issue, you have to be very aware that that known issue is probably going to come back to you at some point. So if you also think about software engineering as an impact to society, even if you had no interest in computer science at all, software engineering itself would still affect basically everything about your life. So if you think about from the very first time you wake up in the morning to the very last thought that you have when you go to sleep, a lot of those tasks in between are facilitated, if not completely automated, by software engineering. So we have technology that makes you wake up, you have technology that facilitates you doing your job, that takes you to work, that takes you home from work, that helps you acquire food, and then helps you fall asleep in a lot of ways. I think the app of the year several years ago was the Calm app. That's all it does, is try to make you calm and go to sleep. And so most of this idea around software engineering and its impact on society is predicated on this very simple concept of shifting complexity, and that's where we're going to go next. So if you think about life prior to software, it was extremely complicated, and it was not necessarily something that a quote layperson could deal with in certain industries. So if you think about trying to work at an extremely large multinational bank, and prepare some financial reports without a database, without Excel, without any sort of data-driven or technology-driven data analytics tool, you would literally be sitting in a room at a desk with a huge paper ledger, and you would have to copy all of that information to various other ledgers, build your own bar charts on graph paper, and all sorts of crazy stuff. And obviously, that has a significantly larger amount of tedium than just doing your job in Excel and kind of distributing the information from doing that job. So a lot of the role of software that is created by software engineers is to kind of absorb all of this complexity. So instead of having to by hand copy a bunch of data from ledger to ledger, and then by hand using a pencil and a ruler and whatever build some charts, you can have Excel do all of that stuff for you. And what that does is it allows you to kind of free up your time to think about the heady things related to the accounting, and not necessarily the nuts and bolts, sort of brass tacks of building charts and copying data from place to place. So that's great if you are a banker, if you are an accountant, if you are a lawyer, if you are trying to do these non-technical things that have now been made easier through technology. The counter of that is that software engineering itself is extremely not trivial because it's been generated to do non-trivial things. What you're doing as a software engineer is you're trying to automate all of this really complicated stuff that originally was done by people who were receiving specific training in order to do this complicated stuff. And so largely because of that complexity, we have shifted a lot of work from technology to, or from humans to technology. And in doing so, we have created these very, very large applications. And so if you think about the largest application that you've created as an undergrad in computer science, it's probably on the order of thousands or tens of thousands of lines of code. But here are several examples of things that a lot of people use every day that have hundreds of thousands, if not millions, of lines of code. And so a lot of these things are not applications that you would necessarily think about off the top of your head as being a software engineering situation, like the Chevy Volt, for example. So the take-home message behind all of this is that while it's possible for you to create your own MIPS simulator by yourself, it is not necessarily possible for you to generate Microsoft Windows by yourself. So what ends up happening is instead of one person doing the job, you end up in a software team, and that is where a lot of the complexity of software engineering really starts to balloon. So if we go through the thought experiment of you being the most incredible rock star of developer in the modern history of software engineering, let's say that you could generate 10,000 lines of absolutely pristine code a day. It is unit tested, it is known to be fault-free, and it is just the greatest code ever, so that you don't necessarily have to spend any other time documenting it, you don't have to spend any other time troubleshooting or patching it. It's all perfect. First of all, that's a tremendous amount of code. So if you think about having only 8 hours in a day, that's more than 1,000 lines an hour without you actually ever even stopping to think about what you're actually supposed to be doing with the code. So that's probably not even a human amount of code to write. So even if you're trying to generate this fairly simple case that we saw in the last slide about an electric car controller, that would take you almost 3 years wall-to-wall just coding. It has nothing to do with debugging, testing, designing, the actual code, solving the problem with pseudocode, none of that. That is only you typing on a keyboard. And that is where we get to the idea that software engineering is almost by definition a team sport. It isn't necessarily something that you even want to do by yourself, because nobody wants to generate 10,000 lines a day for 3 years in order to just have a product to begin with. So while you have experience programming assignments as an individual developer, that's great. A lot of those skills will transfer directly to team-based development. A lot of them necessarily won't. And so what this means is that as a software organization, if you go out and you try to get people to apply for software engineering jobs, you will find a tremendous number of people who know how to code. You will find a tremendous subset of those people are very good at coding. They're also very good at designing solutions to problems. And you'll find a large subset of those people are really good at doing hyper-specific things like database management or UI development. But if you try to find a person who can not only do all of that work, but can tell someone how they're going to do that work, and also work in a team to do that work, not necessarily on their own, but through delegation and through transparency and through being honestly just kind of a team player, you're likely to see much fewer job candidates. And so like I said in my sort of biography on Canvas, I run a software organization in Tallahassee. We are constantly kind of looking for software engineers, and that is absolutely the experience that we've had. You can always find a person who knows a specific programming language. You can always find a person who has a degree in computer science that can generate code. It's very difficult to find a person who has that technical ability in addition to all of the sort of soft skills that you need them to have for them to be good at software engineering in a team setting. So what this class also wants to focus on is things like the ability to communicate what you're doing with your teammates, things like time management to make sure that you're not spending too much time on testing or too much time on designing, things like effort estimation to make sure that you can actually promise in your group project something that's deliverable. And if you put all of these things together, you get a situation where you can be maybe not the best programmer on a team, but you can certainly be a good programmer that's also a good team member, and those people are almost always going to be the people who software organizations want to hire. If you hire the best programmer, but that programmer is a jerk, nobody's going to want to work with them, and you're not going to get very much positivity in the organization out of that person. So because of the whole teamwork situation, one of the very most key aspects of software engineering is communication. I taught this course last semester, and I preached this over and over again. People kind of giggled, people kind of laughed, and then we got into the second iteration of the group project, and it was sort of like watching maybe half the groups run around, half of the team was on fire, 3 people were just sort of staring into space, and that's a lot of the experience that you will get if you don't necessarily have a good strategy around teamwork and communication from the very beginning. So one of the things to think about, particularly in the age of COVID, is that you don't necessarily understand how someone else's life is going outside of work. So you don't necessarily know if someone is not providing a lot of good software, a lot of good code, or a lot of good testing because they're not good at coding or they're not good at testing, or if they're just having a really hard time because a family member just died or something like that. So it's really important in this group project, but also just in your life in general, to be good at communicating when bad stuff is happening to you. You don't have to necessarily provide detail, but people need to know, right, when they need to pick up slack. And it's important not only from the group work perspective, but it's also important from just getting a job, right? If you can help people when they need help, and you can ask for help when you need help, your life in general is going to be a much, much, much better situation. So also we talked about the fact that you can't necessarily just rush through a project in software engineering and then send it out to market and then run away. So it might be true that your programming assignment will be around for 2 or 3 weeks. And then you complete it, you take your grade, you come to acceptance with your grade, and you move on with your life. There is a tremendous amount of software that is running on COBOL from 30 years ago right now today. And so what you need to think about in terms of building software solutions is that software solution could very realistically outlive you. And so you shouldn't cut corners, you shouldn't necessarily do untoward things, because all of them will ultimately come back to haunt you. And even if you leave the organization and someone else is stuck with the bill, you don't necessarily want to put somebody in that situation. So while programming assignments in a course are just kind of, they are what they are, software sticks around in industry for quite a long time. So while you can just sort of take the grade for what it is in a programming assignment, you can't necessarily just send a half-baked application out into market and hope that people will buy it. What we're going to talk about a little bit later in the course is the impact that bugs, the impact that cutting corners has on the actual software organization. And if you think about people who have tried to build iPhone games as a great example. So if you think about Niantic and Pokemon Go, it's a fairly successful application, but at the very beginning they had a lot of problems around trying to cut corners and trying to get a thing to market to generate revenue when they needed it, when they could have maybe taken a little bit of extra time and kind of finished baking it out. So in conclusion, what I really want to get across with this first video is that you might be sitting in your desk chair right now watching this video thinking that you are the absolute greatest C++ programmer that has ever lived. And you might have years and years and years of experience with C++, years of experience with Java, and you might be actually the greatest programmer in the world. But that does not necessarily imply that you're going to be a great software engineer. And the purpose of this class is to make sure that you're given the tools and the experience necessary to be a great software engineer. So this class is not going to necessarily beat you over the head with a whole bunch of hyper-technical language implementation style stuff. What it's going to do is try to help you take the technical skills that you already have and then use those to become a very good, very hireable software engineer once you're done with your schoolwork. So, like we said, being a great software engineer requires technical prowess, but it also requires soft skills. And so we're going to go over the kind of gambit in the course. We're going to talk about communication. We're going to talk about how to manage projects. We're also going to talk about how to structure applications. We're going to talk about architectural design. And hopefully, through all of those experiences, you'll get kind of the broad swath of all of the different things that software engineers have to keep in mind daily. And so the purpose of this class is to make you a successful software engineer. So its goal is to, upon completion, you should be able to go out and get an internship with Google. You should be able to go out and get an internship with Microsoft and feel comfortable. You should be able to understand all of the words that they're using for their processes. You should be able to meaningfully contribute to code, meaningfully contribute to the software development process. And you should do so without having to go through a whole bunch of ramp up that's both stressful for the organization and stressful for you. So we're going to leave this lecture at that, and next time we're going to get into more of the details around maybe the history of where software engineering came from. So if you have questions, comments, concerns at any point through the class, you can always reach me at crmills at fsu.edu, and I'm happy to respond to your questions. And we'll also have office hours, and we'll also have the sort of weekly meeting on Fridays where you can ask any questions you like. Thank you very much for your time, and I hope to see you all soon.